So welcome all to the second core community call. There is a number of agenda items that we've had proposed for this call. Currently, the list is first going over program runtime V2 with Alexander Meissner and Alessandro, and I think Aditya as well, if he is on this call. Then there was kind of requested as well to go over the transaction instruction limitations and figure out like what makes sense on both the Firedancer as well as our side to implement. And then finally, if we manage to make it and have time, we'll go over with the Mango team, their application account right fees, SIMD, and we'll go forward. So quick housekeeping note. There is, for future agenda items, we're going to create like an issue for people to propose agenda items on, so that it's not just reach out to someone and hope that it happens. So I'll put the link to it here. And that ultimately, though, for anything that gets proposed, we should have at least some documentation on it. It should be ready to discuss. It shouldn't just be an idea. But yeah, from there, Alexander, Alessandro, Aditya, if you're on, feel free to get started on program runtime V2.
Okay, yeah, thanks. Thanks for the intro. Let me try to share my screen. Let's see. Zoom and full screens. Okay. Yeah, can everybody see it?
Yes.
Okay, cool. Yeah, so huge upcoming project. First of all, disclaimer. Everything is still a draft. It's not even a proposal yet. You won't find it in the SIMD for now. Yeah, still lots of things to change. Timelines are still being worked out, and this is mostly a teaser to get some community feedback. So if these are things that you, the programmers on the chain, think are valuable to you, if this is something you want to see, or if there are things where you think like, oh no, this is never gonna work for us. Okay, so biggest relevation is we want to support the Move programming language. Some of you might have heard of it. It's actually, we had very originally, even before the launch of our mainnet beta, we had support for Move at the very beginning, but we sketched it and we then implemented our now current Rust ecosystem. So in that sense, actually Move is coming back to Solana. But this time we plan on actually compiling it, having it compiled and verified at deployment, which is something new. I think other chains so far have only been trying to interpret it. And further beyond that, we want to make it interoperable with the other front ends. So with C and especially with Rust, which brings a lot of challenges, but also some very interesting opportunities. So yeah, what will change in the program runtime? Programs will become libraries, essentially. So all the programs will be able to export types as well as constants and functions, count as constants. All the functions will have static parameter and return value signatures. No generics allowed on these public functions. And every public function will then be able to become an entry point. So currently, if you're not using some boilerplate hiding framework like Anchor, you would have noticed that you have to, or basically everybody is writing something like a dispatcher in the entry point, where they deserialize the incoming instruction and then immediately call in something like a switch case or a matching pattern, call another function. So that would not be necessary anymore. You could just call into the right function directly and have it be using a type interface. And also accounts would become types. So currently you have to use serialize and deserialize, and you need to know what you're doing and what your bytes are and how to interpret them. And in this new runtime, we would essentially give every account type similar to a structure. It is not yet decided how dynamically sized vectors are going to work in that, because obviously, as you know, structures have, in Rust at least, and also in C, they have static layouts. So there is no concept in these programming languages of dynamically sized inlined members in structs. And also, possibly, you might have to statically declare dependencies. That's also not decided yet. So by dependencies, we mean the other programs you import types from and you use functions of. Okay, the other big change is gonna be finer sandboxing. So currently it's sandboxing, the idea of separating programs coming from different developers so that they cannot misbehave beyond their own little sandbox. Is completely done by virtual machines and separated virtual address spaces. And we have one for every single instruction in a transaction. And that is very inefficient. So in the current architecture, we actually copy all the data in between the instructions. We have a feature ready-ish, soon TM, which will instead memory map and share the memory, at least in between these VMs of the accounts. But still, the programming model is and continues to be, well, for the old program runtime, that every single instruction gets its own new virtual address space. And in this new runtime, we want to change that. We want to make one big VM and one big address space for the entire transaction and share it across all the instructions. And instead have a way finer-grained access control system, which basically does access control per allocation or per memory object. So you would be able to declare a type, to make an instance of that type, so in some data, and then you could obviously store it in your own account and retrieve that from it, but you could also, that's another interesting part, you could also pass it to some other program. And that program could also store it in its accounts and retrieve it from that and pass it along and so on. And all these programs would be prohibited from modifying the data. So for them, your exported types would be opaque. So now you would be wondering, like, what's the sense of exporting types when you can only have opaque types, right? So the idea here is that if you want to do something with that object, which you got from somebody else, you return it to them. You call them and say them, please do this modification. And now, as they are the owner of the type, they hopefully then know what should be possible on this type and what should not. So in this sense, what this allows, completely speaking now, is you could have assets declared in every single program. So for now, currently on the chain, you have to use, for example, like the token program to have a token, right? And with this model of exporting types, which are only modifiable by the program which exported the type, you could have every program be its own token program in that sense. Okay, and with this comes also a change in how CPI works and syscalls work. So currently CPI calling one program in another program is really expensive and just slow and limited. So instead we want to make that more like a function call. Essentially would be passing like the instruction parameters and the accounts or small parameters like we would in a function call. And syscalls would be replaced by CPI to build-in programs. So currently, some of you might be aware that syscalls are a special mechanism, and that would also be going away and just be treated as another call to another program, which happens to be a built-in program. Yeah, this is actually the least clear for now what the exact new limits and costs are going to be, because it obviously depends a lot on the specifics on the implementation. But what we want to achieve here is to remove some of the most annoying limits. So one of them, probably most of you have encountered, is that you can only reallocate accounts by a fixed amount of 10 kilobytes per instruction. And if you want to do more, you have to do a series of instructions. And you can currently only do 4 CPI nested in each other, because that also means that we have 4 VMs suspended simultaneously, right? We need to keep the memory alive for the outer VMs. So this is why it's so limited for now. Both of these limits should be gone. Additionally, a limit is that we have a fixed stack, and this stack is quickly consumed by the fact that every function call gets 4 kilobytes of stack frame for now. And we're switching to a dynamic stack pointer so that the compiler can actually dictate how much stack memory it's going to use in which function, and then hopefully more efficiently use the stack, which should enable more or deeper function call traces. Yeah, CPI, as I already said, is going to be cheaper, so we will also calculate less U for that. It won't be dependent on the account size anymore. I think that's also a limiting factor for most of you. And syscalls might be slightly a bit cheaper. Then we probably going to introduce a cost for declaring programs in a transaction. Currently, that is free, as far as I know, because we might switch to eagerly loading programs, which is currently lazy loaded. And there will be one base cost for invoking a program, independent of if this program is doing anything at all or just returning immediately. This is also not the case. Currently, there are different costs associated depending on if this program is a top level declared in the message of the transaction or generated by CPI. Yeah, then things which we are not going to change, or in other words, which stay. Rust will still be the main programming ecosystem. So it's not that we are moving to move we're staying with Rust. We're just also implementing Move for people who come from Move ecosystems and want to program on Solana. This is just part of the motivation. Bigger part is that we want to bring these concepts of Move, like having every function a possible entry point and having typed accounts. We want to bring them to Rust. And yeah, the the one pain point you all know about, having to declare all possibly accessed accounts and call programs upfront in a transaction, that is going to remain. It has to do with how the transaction scheduler and batching works. And if you don't, or if the program runtime doesn't know that upfront, it gets really hard to do this efficiently. So this will remain something which probably needs some outer solution, like simulation of the transaction to figure out which programs you actually want to call, and then submitting the instruction. Then, yeah, the account model is mostly unchanged. That will stay more or less the same. Like the accounts database is still a key value store for the most part. The rent field is being deprecated, but that's already on the way. And the type field is going to be introduced. Now, the interesting thing for you is probably how are we going to migrate from the current system to the new system. So we plan on doing a long migration period. By long, I mean a year, at least I think, in which we will support both runtimes. And you will be able to call the old runtime from the new one, not vice versa. This gives you the opportunity to move all your funds into the new programs. And in general, all these changes are so fundamental that you probably have to rewrite and redeploy all the programs completely. So this is one big migration movement, essentially. And therefore, we only want to do one, so that the community doesn't have to, do multiple waves of redeployments. We want to prevent that, and we are trying to squeeze it all into one big update, essentially. Yeah, so this is it for my presentation. And now, yeah, for questions.
Cool. Thank you, Alexander. Yeah, being cognizant of time, we have about 8 minutes left. So if people have any questions, especially from the fire answer side, since this was a request,
I have a couple of quick reactions, and I also, in the interest of time, are just, instead of asking a question, I'm just going to rattle off a bunch of things that I was making notes on as you were going. I think overall, my kind of quick reaction, I wouldn't consider this the official reaction, but this is the first time we've seen anything more in detail about it, is there's a lot to like here. There's a lot of devils in the details, though, that we would have to sort out. The more maybe down in the FireDancer code base, the way we structured it is we actually started from the programming model we put together for Pyth for running stuff on chain. And then we've extended that to cover x86, and we're writing all of our code within that to give us a lot of flexibility for writing both implementations to run stuff on chain and also do stuff on chain. And give us some cross-platform capabilities and interoperability with various kinds of hardware accelerations and whatnot we're planning. With all that, like what you're describing nicely maps onto that. So I'm not seeing anything there that structurally impacts at a very low level a lot of our development plans. Where things look a little bit more is on the logistical side, which is what's the kind of time frame expected for this? What's the, how how, certain is this? I know you mentioned this before, not even a proposal, just a thing kind of throwing out there. And then when we're looking at it, we're essentially like, my thing is, should we be targeting to just implement this, or we should implement both, or we should target the old thing and then wait to see if this happens? And then, you already addressed this a little bit. What's the kind of thinking around interoperability costs and, some of the details that would go in there. I think there's a secondary thing that would be in there that is also, we've done a lot of work on cost estimation. We're spinning up a lot of our internal quant resources to do even more elaborate work on there. And if this is going to change the cost models, that changes some of the quantitative research we'd like them to be doing on existing transactions. And so more details on that would also be of interest to us. I'll shut up now and let other people talk, or try to get in the remaining 5 minutes. It's done. Sorry for talking really fast there. I was trying to cram a lot in the interest of time.
Yeah, just to quickly try to answer them. So, like I said, timeframes not clear at all. We like our like most optimistical one is to have at the end of the midterm something on testnet, but like really, really minimal MVP, with most of the features missing, just to have some rough idea what this is gonna feel like. No documentation, no support whatsoever, just really the raw code base, the skeleton of the code base essentially. And for how committed are we on this? This is actually spawned out of another project which is going on for 2 years now to reform the existing program runtime. And I think we have reached the limits on what's possible without breaking the API. So this is all the things we have collected in the last 2 years, which are wrong with our current architecture and how we want to reform it. So I think there's definitely something coming in this sense. If it will be exactly this thing which I just presented to you, that is still up to debate. And the other thing about FireDancer, yes, I most likely expect you will still have to implement the old program runtime because of this long migration period. So we're speaking here about maybe something ready on mainnet in a year, and then another year of migration period. So if you only start implementing the program runtime in 2 years, then you might get away with not implementing the old one. But if you want to be faster, then yeah, you would have to implement both.
Thank you. Yeah.
Okay, with 4 minutes left, does anybody want to get into any other questions?
Can I raise my instruction limit request?
Go ahead.
So some of us talked about this in the Discord, but we're interested in limiting the number of instructions in a transaction because especially as a transaction size grows, or as the maximum like MTU grows, then you have this problem where someone could put like 1,000 instructions in one transaction and they're useless instructions, but we don't want to support that basically. And we don't think there's a compelling use case for it.
Yes. This is already independently of this project. We have a feature for that already on the schedule. This will be limited, I think, to something like 50 or 60.
Oh, even better.
Yeah. So we measured what the longest currently used transactions are on the system, and it was something around 40. So we thought, yeah, limited to something slightly above that.
Okay, thanks. So this is a feature flag that has not been activated yet?
Yeah, but it's already on schedule.
Okay.
If you ping me on Discord in the virtual machine channel, then I can send you the GitHub issue.
Sorry, which channel?
Virtual machine.
Virtual machine, got it, thank you.
Okay, Is there any other questions on the runtime v2? And apologies, Mango team, I don't think we're going to be able to get to your SIMD yet. Okay, cool. So thank you all for coming to talk about this. For the future agenda items, what we're going to do is we're going to have it all on GitHub. And I'm just going to create a new issue for the next call. And if you want to propose a new item for the agenda, you can just leave it there. And then hopefully we can get more information there, as well as like documentation ahead of time, so that we can have a more productive conversation when we get to this call. I think we might have to make this call longer in the future, depending on what the agenda items, or do it more often. I'll reach out to y'all to decide on how we do that. But yeah, thank you everyone for coming today.